Okay, so we'll, we'll go about this simple thing called logs. Okay, and what I would love you guys to understand is, firstly, how do we define a log? So I would say a function. Okay, so I'm saying a function which is defined by f of x is equals to log then base b then x. This is what we are calling as a log. That's the definition of a log. Now let's look at something here to understand what I'm trying to talk about. Okay, so logs can be related to indices in some way. For example, if we have something like 3 to the power 2 is equals to 9, how do we express this in forms of a log? So what we're going to do is that this one, the 9 there, is going to be this base here, there the x there, that part that I wrote as x, then this 3 here is going to be our base b there, then the function there, we're going to equate it to this power there. What am I trying to say? To write all this in form of a log, we're going to say log, okay, I said 3, then we have the 9 is equals to 2, which interprets, or rather means that when we say log base 3 of 9 is equals to 2, meaning that we are saying which number can we raise 3 to give us 9 there. So that's what I'm trying to say when I say a function is defined by f of x is equals to log base b of x. Okay, so now what if we have something like this, x to the power 3 is equals to 10. How do you write it in logarithmic form? So same principle there. We have this is going to be x there, as the 3 was the base there, the x is going to be what, the base. So you say log x, then you have 10 there, which is this side you put the power which is 3, like that. Okay, so let's continue. Now how do we change them? Like for example, you're given this, you're changing from the logs to the exponential, like changing them back to their original form. For example, if we have something like this, log okay, so as I was saying, how do we change them back to their original form? For example, if we have something like this, let me use the same examples. Maybe we have log 3 then 9 is equals to 2. how do we take this back to the exponential form? Okay, so as I said, how do we first, we start by interpreting the left hand side. Well, we say, okay, log 3, they are having the 9 there, means that which number am I going to raise 3 to give us what? 9. Okay, so which is the what? The 2 there. So we have 3 raised to the power 2 will now give us what? 9. But I believe these are just basic things that you're supposed to understand. Okay, what I'm interested in is this, where most of you guys start thinking logs kosa shani. Okay, properties of logs. What properties are we supposed to understand? Okay, the first one. Okay, to understand the properties of logs, we're going to take two letters here. We're going to use let's say we say a, we say a is equals to, let's give a something. We say a is b to the power m, and let's say c is b to the power, sorry, let's that. Okay, let's give a certain number. Letter c is b to the power n, and now we first start by writing these in logs form, as I told you there. So what will happen is that this one we say, okay, for this part we have log, this one is going to be there like that, then this one we are saying which number we raise this to that, giving us this, so it's going to be like that, then the power we put it there. From what I was teaching you here, how we interpreted that there, so that I'm just trying to do. Then the c there is the same thing. We want to write this exponential form into logs, so have log, okay, this one, the b, then equating that answer that we have, and the power will always be this side. From here we are going to be driving some rules. What first rule are we going to drive there? So let's take, for instance, we happen to have this, we say, okay, let's say p we say a multiplying with the c. What are we having? So on the a we have what? We have b the power m, okay, then times, if there's no sign there, it simply implies that we're having a multiplication sign there. Then on the c we have b the power n. Let's try to interpret these using the rules of indices. When we have the same bases, the powers do what? Add. So we have the base b there, the powers adding, which is m plus what? Plus n. Okay, so now let's get this part. Let's try to ignore this part and just deal with that part there. So we have a c is equals to b then m plus n. Okay, let's write this in forms of logs. Yes, okay, so this one, that's the way we did this. So you say, okay, log AC is equals to what, the power, which is m plus what, plus n. Okay, okay, so we have this there. We've written this in form of that here. Okay, so let me just take that same part. I'm bringing it to a certain rule here. Okay, so let me just erase this so that we have space to see the first one to grab me. The other one I'll just give you guys. Okay, so let's erase that there. Okay, so I'm saying, okay, in this part, okay, let me just start from there. So we have log, so we have log b, then AC is equals to m plus what, plus n. Okay, what am I trying to bring up here? Okay, so the rule that I'm trying to bring up here is that we can try to start by separating this here. So we'll say, okay, let this log, let this be like this. We have log b attaching to a, and another log b attaching to what, to c. Okay, now what we are going to notice there, okay, so we multiply that there, then we have m plus what, plus n. What we can just do is, let me not even go very further, I might just confuse you. Okay, let's just do this. Okay, so let's go on top. Let's show you something. Interrupt that. Okay, set this part here. Okay, remember we started with saying a is something like b to the power m, and c is something like b to the power n. And I said when we write this in log form, we're going to have m is equals to log log b, then a, and c is going to be sorry, not c but n is going to be log b, then c. So what we're just going to do is that this rule, as we came here on the m, we'll place this here. So we'll have, let's get this part here, this part. So we'll have log b, then ac is equal to m, we'll put log b, then a, plus on the n we'll put log b, then c. So this is one of the what? One of the rules that I want to bring to your attention when we are dealing with logs. Okay, now what happens? So this is when you're multiplying. Now what if when you're this is the first rule. What if when you're dividing, what happens? Okay, so this one I'm going to be fast, just driving that to show you guys. So the second one, 2, is that when you have the log of b, then we have a over c. This one just gives you the subtract. So you say log b a minus log b c. You subtract there. Then what other rules are you supposed to put in place and do? Okay. So the third one, 3, when you have this p, maybe raise the power k, being equal to maybe let's say b to the power m raised to a power k. So what we do there is that just rub this, not clear. Okay, so I'm saying we have here b raised to the power m and k, like that. So what we're going to do there, let's get rid of this. Okay, so what we're going to do there is that this in fact it's not even, I see, so it's supposed to be m there. Okay, it's just all my brain complicated rules. Okay, okay, so 3, we have log power there. Okay, so what we do is that just introduce logs there. So have log of p raised to the power k is equals to b, like that. So even though we put a log k, so what will happen is that if people are trying to find the k there, this power will drop there. So have k, then log p is equals to log b. To have the k, we divide by log p, then log p. We cancel there like that. So our k is just simply log b over log p. Okay. Let's go to the examples. I've wasted a lot of time here. You know these rules, guys. Just giving you basics. Okay, so we're going to use the properties of logs to expand the following. The first one, so let me say example. So the first one is where we have log equal to 5, then in brackets we have x y the power 2, like this. So how do we expand this one? So remember, we are multiplying there, multiplying. So what do? We had this, remember we had this, so we had log b of a and c. It's not different. What did we do? We just, in short, just distributing this log b to the a plus log b to the c. When you're multiplying there, you just add there. So we're going to have log b distributed to the a, but since we're multiplying, we add even the log b distributed to the c. Same with that. Okay, so put there. Yeah. Okay, so here just simply log 5 to the x is equal to log 5 to the x plus log 5 to the y to the power 2. But since we have a power, is supposed to drop there, so have log 5 x plus 2, then log 5y distributed like that. Let's move to, let's have the other example. So okay, second one is we have natural log in of this e square root of y over z squared. So remember, here we're multiplying, there we are dividing. So what will happen there is that they are same rule. If we want, we can put a log there and apply the same rules. So since there is ln there, we just work in the same, using the same principles. So we have in, remember we are multiplying there, so we have e, since we're multiplying, we put a plus, then into the root of y. Since we're dividing there, we have minus e in z to the power 2. So there we have ln of e plus ln of the root of y. Since we have a power there, to drop minus 2, then in of z, like that. Okay, these things are easy, guys. These things are easy. These things are very, very easy. Let's have something else there. Okay, I think the last one is going to be the last example. Then we are done. Then we'll continue the other time. Just wanted to give you guys a demo of type of lessons that we're going to have using this, and this thing is so how our lessons are going to be conducted. Let's have the other example. Okay, so just applying the same properties. So here we have this having the same base. We are told to say use the properties of logs to rewrite each expression as a single logarithm with a coefficient of 1. So this one, want to rewrite this one, log 5, then x squared minus 4 plus 3, okay, plus 3 log 5, then y minus log 5, then x minus 2 to the power 2. So guys, here we're just applying the rules, nothing is different. We are adding there. We want to take this to their original forms, the way they were they were before before bringing in these signs. Just want to bring them back to the original forms, the way we found them. Okay, so what is going to happen here is that first you're supposed to maintain these malogs. So e3 yarakweleka first before we start applying. So we write this log 5, then x to the power 2 minus 4 plus log 5, y to the power 3 minus log 5, there it's just okay, then the power 2. Then let's apply the rules. Since these are the same, just not nothing is complicated here, just all these logs, bring them together. Log 5, log 5, log 5, write it as log 5. On top there, since it's this and this one, let's forget about this. Since this and this is there is an addition, this will multiply, so we'll have x squared minus 4, okay, multiplying with y to the power 3, like that. Then since there's a minus to this, even this one, forget about it, we'll have that. Then we'll have over, since there's a minus, we say x minus 2 to the power 2. Okay, so this is what we're talking about. So these were just simple examples, and this is where we end for today on logs. We're going to continue and do more complicated examples, but this one that I've brought here, I think I saw it in one of the papers, but though there was something that we were supposed to, yeah, this is how you answer it when you're told to express as a single logarithm of a coefficient of 1 when you're having the same basis. But what happens when we're having different bases? That's what we're going to do the other time we happen to meet. Okay, so looks know how to deal with these things, guys. Know how to deal with these things. These things are easy, guys. Study. Just sort of making this cutting for you guys. I've missed you guys. So for now it is bye from this guy, Samist.